These videos are for February 24th and should have been 27th, but I was out. So if you are at B-Day, we went over this March 3rd. So I'll scratch that out, put 3, 3, 17. And what we talked about is adding, subtracting rational functions. And we're actually also going to multiply and divide. And what we talked about at the beginning is if we're adding or subtracting, it behaves just as if like regular fractions would. So we have to get a common denominator. So if you look at this first function here, we do have a common denominator. If we want to add the fractions, then we can say 3x minus 4. If you look at the numerators, now we can just add our numerators. So if we add our like terms in the numerator, we would just get x squared plus 6x minus 7. Now we could factor the numerator if we wanted to, but then nothing would divide out. So this is an acceptable solution, if you will, by adding these two fractions, these two rational expressions. In B, we notice we don't have a common denominator, but what some students did is said, hey, well, what you can do is this, nothing factors here. So we have 15x, x plus 7. A lot of students left the numerator here the same and then factored our quadratic here. So we want to factor our quadratic in the denominator here. We can find two numbers that multiply to give us negative 63 that add to negative 2. Those two numbers being x minus 9, x plus 7. And when we talked about this, what we said is, hey, they almost have a common denominator. They both have x plus 7. It would be great if we could get this x minus 9. And we could do that. We could go ahead and do that, multiply this by top and bottom by x minus 9, because we don't want to change the value of it. That's why we multiply by x minus 9 over x minus 9, because that value is actually just 1, so we wouldn't change the value. But here in this numerator, 2x minus 18, this can actually factor. 2 goes into 2 and 2 goes into 18. So we can actually rewrite that second fraction, factor a 2 out. If I factor 2 from 2x, I'm left with just x. If I factor 2 from 18, I'm left with 9. Now we notice that the x minus 9, we have a string of multiplication here. We don't have to worry about 2 plus x minus 9. It's all multiplication. These would divide out. And we have 15x over x plus 7 minus 2 over x plus 7. Common denominator. Man, isn't that great? Common denom. Isn't that great? So now we can just say this is x plus 7 in our denominator. The denominator stays the same. We subtract the numerators, we get 15x minus 2. All right. So if we can factor, what would be great is if we can recognize what we can factor initially. That's going to save us a lot of work. So we can factor everything initially. Then hopefully we can get a common denominator. If not, we have to do some extra work, and let's see how that's going to turn out. So let's look here. Again, so let's talk about our first fraction, x plus 10. That cannot factor, so we would leave that as x plus 10. If we look in our denominator, we have what we call a difference of two squares. X squared, that's x times x. 1 squared, that's 1 times 1. So anytime we have a difference of two squares, so for example, if we have x squared minus 25, this can become x minus 5, x plus 5. Same thing here, this would become, similar thing here, I should say, x minus 1, x plus 1. Now, unlike the last one, nothing divides out here. So they both have x minus 1 in common. This one just needs an x plus 1. So we can give it that x plus 1. We don't want to change the value, so we multiply by x plus 1 over x plus 1. And we can't forget distributive property. If we distribute 5x and 1, so 5x plus 5. 5 times x is 5x. 5 times 1 is 5. And then we can combine our like terms like that. Let's go on to part D. Again, we want to factor everything that we can. So again, 5x cannot factor. We leave as 5x. Our denominator here, notice we have x cubed and x squared. So we should be able to factor something with x. In fact, they have 2 in common. So we can factor out x squared. If I have x cubed, I factor out x squared, we're just left with x. 4x squared, I factor out x squared, we're left with minus 4. And then I would recommend you doing the AC method here. I can go ahead and factor that though. I would recommend you pausing, trying it on your own, make sure you end up with the same thing. Got to use the brain here. Oh, give it some room. Now hopefully we notice we're close. We have x minus 4, x minus 4. What we need to give this side is a 3x minus 1, so we can do that. Because if this has 3x minus 1 in the denominator, then we're close, as long as this side has x squared. And we can give that x squared over here. Now again, distributive property, 5x times 3x would give us 15x squared. 5x times negative 1 over. I'm going to just move the x squared in the front. $11x squared. Again, I'm just going to move the x squared in the front. Now we have a common denominator, and we can go ahead and simplify. So our denominator does not change. X squared, 3x minus 1, x minus 4, 15x squared minus 11x squared, we have 4x squared minus 5x. Now what we need to be careful with is simplifying fully. If you look in the numerator, we have x squared and x. We can factor out an x here. They both have an x in common. And what's actually going to happen here is that you have an x in your numerator, x squared in your denominator, x squared. What's happening here is one of these x's will cancel out one of these x's. So what we would ultimately end up with is 4x minus 5 over x, 3x minus 1, x minus 4. So that would be our simplified expression. Now I'm going to encourage you to try the next few on your own. I'm going to show you solutions to end this video, and then I'll do another video with multiplying and dividing. But I highly recommend you pausing, seeing if you have questions, ask me through the Remind app, email, things like that. I'm going to go ahead and show you the solutions to the other ones. So if you add number 1, get a common denominator. You just need to be careful here. You're going to need to use the AC method here, but you should end up with this function. On the back, here, for this one, and here. I'm not going to do 5. I'll stop there. If you have questions, please ask. This is part 1. There will be another video going over multiplication and division.